Okay everyone, another example here. So you got pipe, and that's actually to do with one of your tasks. You got pipe that has a cross-sectional area 0.01. So the area here is 0.01 at inlet. So 0.01 all SI units. And here the area is 0.0025. It's a 90-degree bend. So the bend is 90 degree. That and then that. Yeah. 90-degree bend. The velocity 4 meter. So here the velocity is 4 meter per second. And the pressure is 100 kilopascal. You can convert that kilopascals into Pascal. The density of the fluid here is same as the density of the fluid here. The density is not changing. Find the force acting parallel and perpendicular to the initial direction. So parallel is going to be that direction, perpendicular is going to be that direction, the y-axis. Okay, how do we do that? First thing we do is we use an equation of continuity. Equation of continuity mean the flow rate at the inlet should be same as the flow rate at the outlet. Outlet I'm calling number 2, inlet I'm calling 1. Equation is A1 V1 equals A2 V2. Yeah? Where A is the area, V is the velocity. Now let's say, do I have the area 1? Yes, I have the area 1. I have the velocity 1. I have the area 2. But I don't have the velocity 2. Velocity 2 is missing. Let's find the velocity 2. To find the velocity 2, I need to rearrange the equation. V2 A1 V1 over A1. A2. I put all the values and I will get velocity 2 meters per second. Yeah, let's say it's any specific value. I got this value, velocity 2. Now the question is asking me to find out the force acting parallel, yeah, and the force acting perpendicular. Now what I'm going to do now is I need to apply the Bernoulli's equation. One thing you need to know is this thing is going to the outlet. So here the pressure P2, I'm going to call it like a 0 Pascal. Yeah? P2 is 0 Pascal. P1 is given, but P2 is 0 Pascal because it's going to atmosphere. So 0 Pascal. Now I will apply a Bernoulli's equation. When I apply Bernoulli's equation, I need to actually let me have a look. Well, for the pressure we can find the Bernoulli's equation, but I already know the pressure to it's 0 Pascal. So in that case I don't have to use the Bernoulli's equation at all. So there is no need of using that one. Now I need to find the forces. I have the velocity, I think from here, from the previous one. Make sure you check that thing. Here they give me 16, but make sure you do check if that 16 is right. Make sure you check that value. Okay. Now the next thing I need to do is I need to find out the pressure and the forces. Okay. To find the pressure and the forces, V2. Now first I need to find out which direction is the V2. V2 is this direction. This is V2 and this direction is the V1. So if I draw V1 and I draw V2, V2 is 16 meters per second. Make sure you guys put the values and check it. And V1 here was 4 meters per second. And I need to find out the total, that force. To find that force will be the force acting on that part. Yeah. To find that one, what I can do is, I can actually use, because it's a right angle triangle, I can use the 4 square plus 16 square square root. Yeah? I need to find the hypotenuse. So that is, I call it delta V. So delta V is the adjacent square plus that square root. That will give me a value 16.5. So this is the value I got, 16.5, which is the kind of that velocity here. Okay. Now I need to find that angle. If I need to find this angle, the angle is the y divided by that bit, yeah? Divided by the x, the theta. Theta has a formula. So there's a formula. It says theta equals tan inverse, this is the direction, over 16 over 4. Obviously this 16 I should write minus 16. Why? Because it's downward. Yeah. So that will be tan inverse minus 4. If I write down minus 4 equals, now where is the tan inverse? Standard, scientific, trig, second, tan inverse. Minus 4 equal minus 4, and then that tan inverse is minus 75. Yeah. So the angle is minus 75 degree. Yeah. If I want to find the real angle, I can do 180 minus 75 degree. So that's 104 degree. 104 degree. Let me see if that looks right. Because that doesn't look like it's 104. 104. Yeah. No, that's fine. Let me see. No, that's fine. Rather than doing that, 104 is from the other side. So we do minus 75 and we just measure it a clockwise direction. So minus 75. We don't have to do this bit. Minus 75 degree is the angle. Minus mean I have to go clockwise. So yeah, I have to go clockwise, and that's minus 74. Now once I got that bit, I need to figure out the forces. To find the forces, I need to use a formula. Force equals to pressure times the area. So this is the formula I got, and I need to find the force on this side, I need to find the force on this side. So these are two forces I'm working on. Okay. Now I know force is pressure times the area. Pressure is given here, that's the pressure, 100, and the area is pi r square. I can do that one, pi r square. Yep. So I need to find out the pi r square. So pi is pi, r squared is that one. Yep. That is the cross section area. So force at inlet, pressure, and the area is, sorry, I forgot the value for the area. It is 0.01. So 0.01, 0.01, and that was, I think, 100 kilopascal. So that will give you a force. So we got the force in newtons, obviously. So when we got this force in Newton, okay, make sure few values here are not right. Okay, so you need to be very careful. Now the density is given. Density is given as is a water. So density is given as 1000 kilogram per meter cube. So then we can use that equation. Yeah. To find out the mass flow rate. Mass flow rate is density multiplied by the area multiplied by the velocity. Now if you want to find the mass flow rate, density, velocity, area. Okay, and the value of the area. Yeah, value of the area is 0.01. And that will give you the mass flow rate. 4000 multiplied by 0.01, so that's 40. Obviously units are mass times second per second, so that's the mass flow rate. Now we got the mass flow rate. After we find out the mass flow rate, it's nearly done. Okay, now find the forces parallel and perpendicular. Okay, so forces parallel and perpendicular. First we need to find out the force, the total force, and then we convert into perpendicular and that one. So to do that one, the force has an equation. F equals to m delta v, where delta v is the velocity. That is a 40. And that's, I think, 16.5. I just rounded off. And that will give me the force. Which is 660. Now, if I need to find out the horizontal force, is going to be F cos theta, where F is 660 and cos 75, I think. 75. Yeah, I just round it off, so you can just put the right value. And the Fy is going to be 660 multiplied by sine 75. And that will give you the answer, and that will give you the answer in newtons. And that's it. Let me save that one.